All right, welcome to Explorations in Math, section 4.4, Computation and Other Bases. This is Professor Rodan, and this is going to be it's a short section. It's just adding, subtracting, but we are adding, subtracting in a different base. Okay, so the main thing you need to remember is that this relates to how, or the why, we add and carry in our system, and also when we subtract, we borrow in the subtraction process. So let's get started. So a few things to remember. Number one, you cannot have a digit equal to or higher than the base you are working with. Okay, so this is something we talked about in the previous section. Okay, let's make a little more. So, okay, so here we go. You can't have a digit higher than the base that you're working with. So, for example, our base system, so base 10, that's our system, has digits 0 through 9. Okay, and just as another example, base 5 is going to have digits 0 through 4. Okay, because once you get to the number where you actually get to the base, like 10, remember that 10 actually means one set of tens. Okay, and no remainder. Okay, so a numeral 10 base 5 also means one set of fives. And no remainder. Okay, another example would be base 2. Oops. This is the strangest one because it only has 2 digits. It has 0 and 1. Okay, highly used in electronics and computer language, 0 and 1. So our first example is going to be with base 2. So you may ask yourself, how do I add numbers in different bases? Well, the answer is the same way you add them in base 10 in our system. The only difference is, if you remember this, you can't have a digit higher. That means basically once you max out, you're going to be counting sets. Okay, so let me go ahead and put another one here, and that is we're going to carry just like you do, in regular addition. Okay, carry over any 2-digit numeral as usual. Okay, so everything's pretty much the same. Okay, so let's try number 1. So number 1, we have 1 plus 1. Now I'm putting base 2 just to remind us that we're working with base 2. Okay, so 1 plus 1 is not 2. or the numeral 2, it is, we have a complete set of 2. So this is going to be one set of 2's, no remainder. Okay? So just like we did in class, you got 1, which is 1 base 2. You have 2 items, you got a set. You got 3 items, you have 1 set and 1 remaining. Okay? So this is going to be what we're getting at here. Okay, so our digit, which is our numeral 1, 0, base 2, we need to go ahead and put the 0 here, carry the 1. And then we have another column, which we're going to add up. We have another, well, technically we have 1 plus 0 plus 1, which is again 2 items or 2 things, but as far as quantity, but in numeral in base 2, you can't write 2 because that's you maxed it out. So we have, again, 1 set of 2's, no remainder. Okay, so we're going to write the 0 down here, carry the 1, and now we have 1 plus 1 plus another 1. So if we were counting something, we would be counting, let's say, 3 chairs. But in numeral, as far as the symbol in base 2, we have this right here. Okay, that's 3. So let's do it this way. This is 1, 2, 3. So this is going to be 1, 1, base 2. So we're going to put the 1 here, carry the 1. And then we have another 1 plus 1, which is 1 set of 2. Okay, so please watch this again if you need to. Email me if any questions you have. I know this is very strange, but we are working in base 2, and this is why we are doing things very differently. Okay, but the concept is the same. We are carrying sets of 2. Okay, when you reach a set of 2, you have to put, you increase your place value. Okay, which is right here and right here. Both of those are 1 set of 2 with a remainder of 0 here and a remainder of 1 right here, or leftovers. Okay, so I just noticed something for some of my work here. This right here is supposed to be a 2. Okay, these are all supposed to be base 2, not base 1. We don't even have that available. So again, guys, so what we just did there in number 1 is the same thing we do in base 10. So here's an example in base 10, which is our base. So 24 plus 87, for example. Remember, we create a new place value, or we use a new place value once we hit 10 or above. So 7 plus 4, we know that's, as far as items go, that is 11 items. That's 11 things. But in base 10, we don't have a digit for 11. We have to say, hey, we completed. So this is like saying 4 plus 7. That is 1 set of 10, and then 1 remaining. This is why we have the digit or the numeral 1, 1. Okay, this is base 10, which I don't have to write, but I'm just clarifying that this is base 10. So we go ahead and write 1 here. We carry the 1. Let me do this in a different color. Okay. Then we say, okay, we're going to add 1 plus 2 plus 8, which is another 11. So this time there's no more that we can carry, so we just write down the number there. This is base 10, right? That's our system. So the same process we do there, we're doing in these other problems. So let's take a look at number 2. Number 2 is base 5, okay? Let me move this a little bit. Okay. All right. So base 5, we have 3 plus 2. Let's go ahead and just write this over here. So remember, in base 5, I cannot write 5. I have to write one set of 5 with no remainder. Okay? So we just maxed out our counting system for base 5, so we have to say one set of 5s, no remainder, so that's a numeral 10. Go ahead and add the 1 on top. Again, we have another 5, right? So 1 plus 4, that's going to be 5 items, but in base 5 numeral, that's again one set of 5s. So we put our 5, oops, I forgot to put this here. Carry the 1, and once again we have another 5, which is came from 1. Oops. Redo that. Okay. All right, so why are we doing this? Making sets of 5s because it's in base 5. Okay, let's go to number 3. Okay, so we have base 11 this time. So the first column is 9 plus 2, or 2 plus 9. And that is, in our system, that's 11. But 11 items is actually one complete set of 11 and no remainder. Okay? So if you want to see how that looks like, so there's 10 items right here. That's where the 1 comes from. And this extra that's out there left over, that's where the other 1 comes from. Okay, so let's take a look at base 11. Okay, so base 11 is a 2-digit base, so we only have 9 digits to represent it. So we have 0 through 9, and then once we get to 10, we got to put A. Okay? And that's where this A, so that A right there that you're seeing is actually a 10 in our system. So let's take a look at the first column. So 2 plus 9 is 11. Well, 11, we're in base 11, so that actually makes one set of 11, and there's no remaining after. There's nothing left over. So we're going to put the 0 right here, carry the 1. Then we have have 1 plus a plus 3. Okay, these are all base 11. So basically, this is actually 1 plus, that's 10. So this is going to be 14. Okay, so even though this is 14, so we definitely have one set of 11 and 14. And then the leftover from 11 to 14 would be 3. So that's the remainder. Okay. Now, take that 3, carry the 1. Then we have 1 plus 5, which is just 6. So final answer, 630 base 11. Alright guys, so when we come to subtraction, I just want to point out that we have this concept of borrowing, okay, that we're going to talk about. But first, let me talk about a couple ideas to remember. And that number 1 would be, again, just like previously, you can't have a digit in your answer that's equal to or higher than the base that you're working with, okay? That means you went over the max and you have to start counting sets of those numbers, of those bases. Okay? So in the previous section, we talked about carrying numbers. Well, in this one, we're going to talk about borrowing. And basically is when you borrow, you are actually borrowing in sets. Okay? You borrow sets of the base you are working with. Okay, here's an example. Base 10, our system. Again, if you don't understand the borrowing in our system, you're not going to understand the borrowing in other systems. So this is an example, 42 minus 18. Okay? So the reason why you were taught is say, hey, you can't subtract 8 from 2, so we need to borrow from the 4. Okay, we're going to borrow one set of that place value are sets of 10s. We're in base 10. Okay? All right? This is base 10. So if you borrow 1 from the 4, you're actually borrowing a set of 10s that you're going to add to the 2 to make it 12. Okay, this is why we write 1, 2. Now you may have been taught, just put a 1 next to the 2, but that's not actual what's happening. Okay, that's what you physically see, but it's not the math that's going on. Okay, you borrow a set of 10 and you add it to the 2, which makes 10 plus 2 is 12. Okay, so 12 minus 8 now. 12 minus 8 is 4, and 3 minus 1 is 2. Okay, so in base 10, that's how it works. And so what we just did was Um, so we borrow one set of tens, okay? And that's what we're going to do in these other bases. So let's take a look at number 4. So here, you can prepare yourself by writing, hey, I'm going to borrow sets of 4. We're in base 4, so we're going to borrow sets of 4. In other words, when I say, I need to borrow from this 1, so now that's 0, okay? And that's one set of 4, so I'm going to add the 4 to the 2, and I'm going to get 6, okay? So that just came from 2 plus 4. Okay, that part you're doing, you have so the 2 that's already there plus the 4 that we're borrowing, because we're borrowing one set of 4s, that makes 6. Okay, so now we do 6 minus 3 is 3. 0 minus 0 is 0. And we can't subtract 1 from 0, so we're going to borrow 1 from the 2. Oops. That's actually, we're borrowing one set of 4, so we're going to add that 4 to this 0, which keeps it at 4. 4 minus 1 is 3. And then we bring down this 1 who's sitting out here by himself, and it's 1303 base 4. Okay, so please stop the video, rewind it if you need to see that again. Okay, let's take a look at number 5. So here we're going to borrow sets of 12s. We're in base 12. Okay, and also we have 0 through 9. Once you get to 10, that's actually A. Okay, because you only have one spot to write the numeral, and 10 is a 2-digit numeral. So 11 is going to be B. Okay, then once you get to 12, you completed a set. All right, so if you get to 12, then that's going to be one set of 12s, no remainder. Okay, so that's the numeral 10. Okay, so that's kind of our basis here. Now we're going to do, hey, B is 11. So this is actually 11. And we know 11 minus 6 is 5. Okay, 2 minus A. Well, actually we're doing 2 minus 10. We don't have enough. So we're going to have to borrow from the 8. One set of 12s from the 8. So we're going to make that a 7. And so now this guy, this 2, we're going to add 12 to it, and we're going to get 14. Okay, so this 14 just came from 2 plus 12. Okay, so now we can do 14 minus A, which is 10. So 14 minus 10 is 4. And 7 minus 3 is 4. So the answer is 445 base 12. Let's take a look at number 6. So why don't you try number 6 on your own, and I'll be with you in a few minutes to see how you do. See how you did. So go ahead and pause the video. Okay, so let's see how you did. You can see that you're gonna have to borrow actually, let's say it this way: the 2 needs help and the 4 needs help. They both need help. So you could just do one at a time, or just start from the left and work your way to the right. That's what I did. So I borrowed one from the 6, or one set of 7s from the 6, so with a 6 in that third place value. So it gives me 5, and I'm going to go ahead and add 7 to the 4, which makes 11. Okay, but then I need to borrow from that 11, so I can give a set of 7s to the 2. So we add the 7 to the 2 to get 9. 9 minus 3 is 6. Let me point at these things. So 9 minus 3, 6. Well, we borrowed one from the 11, making it 10. 10 minus 5 is 5. And then the 5 is going to come straight down. And there's our answer. Alright guys, so I just noticed that the key for number 4 is missing a 1, so that's a typo. It should be 1303, base 4. And also you're missing some extra book practice, so we have page 192, numbers 7 through 29 odd. And so what I want to do is work some base 16 questions. So we're going to take on number 17. Number 17 is A734 and 128B, base 16. So as you recall, guys, base 16 has 16 numerals. Okay, so we have the typical 0 through 9 from the base 10 system. That's 10 digits or 10 numerals. So then for our quantity of 10, 11, 12, 13, 14, and 15, we need to supplement with letters of the alphabet. So this is A, B, C, this is D, this is E, and this is F. Okay, so we cannot write any sets of 16 until we pass 15. We actually get to 16. So even though we may come up with a 2-digit number for our answer, we're going to have to use the letters, and we're not going to be able to carry if we use the letters. So let's take a look at an example here. So B plus 4. Okay, B plus 4. Okay, so for the first column we have 4 plus B, and that B is actually 11, and 11 plus 4 is 15 items, but in our base 16 system, 15 has a letter, and that's F. So we cannot put 5 and carry the 1 because we have not completed a set of 16s yet. 15 is not enough for a complete set where we can carry a 1. So we have to write F. Next, three and 8. Well, 3 plus 8 is 11. Okay, 11 items, but in base 16, as you can see right here, there's a B. So I cannot put 1 and carry the 1. I have not completed a set of 16s yet. Okay, then we take the next one. 2 plus 7, or, sorry, 7 plus 2. That is 9. Well, 9 doesn't have, it's not a 2-digit numeral, so we don't need to write any letters. That's just a plain old 9. And then we have A plus 1, which A is 10. So 10 plus 1 is 11 items. but as you can see, it's B again. So our final answer then is B9BF base 16. Okay, I know that's kind of strange, but again, we're working with a bigger base than 10. Okay, where it actually takes more more items to complete a set. Now let's take a look at another number with base 16, and that would be question number 30, and this is subtraction. Okay, so number 30 is also a base 16, it's subtraction this time. So we have 4E7 minus 189. Okay. So we don't have enough. 9 is not enough to subtract from 7. So we need to borrow from the E. Well, what is E? E, if you look at our list on the left over here, E, it represents the quantity 14. So we have 14 here, and we're borrowing 1 from the 14 to make it 13. Then we're taking that set of 16, one set of 16 that we borrowed from the 14, we're going to add it to the 7, and 16 plus 7 is 23. And where did that 23 come from? 7 plus 16, okay? So then we're ready to subtract. So our first column is going to be 23 minus 9, which is 14. Now 14 is not enough for a complete set. We have a numeral. In this case, we have a letter that represents 14, so this is going to be E. Then we have 13 minus 8. Okay. And 13 minus 8 is just a regular 5. And then 4 minus 1 is 3, which is a regular 3. So the answer is 35E base 16. And that is it. Watch this again if you need to. Other resources would be videos from the textbook that you can look at. And I highly recommend that you read the textbook as well, section 4.4. All right, see you soon.